do an example here. The piston is expanding from 0.680 liters to 1.200 liters. The pressure is constant at 1.02 atmospheres. 550 joules of heat are added to the system. And part A is going to ask us to find the work.
I have a question.
Yep.
Okay, so you say 550 joules of heat are added?
To the system, yep.
Okay.
So when in doubt, draw yourself a picture. So here's my cylinder, here's my system, here's my surroundings. The piston is going up. Now, would work be negative or positive? Before we even do the math, we could ask ourselves, should work be positive or negative? Is the piston expanding or contracting?
Expanding.
If it's expanding, work is always negative. What about our heat? Is heat going into or out of the system?
Added.
Added. So heat is going in. So heat is going in, Q is going to be positive. So we can already make predictions about the sign, whether it be positive or negative. Now let's actually calculate the work. Work is equal to negative P delta V. We are given a pressure of 1.02 atmospheres. Pressure, Julia, must be in kPa. So we have to convert that to kPa. 1 atmosphere is 101.325 kPa, which equals 103 kPa with sig phase. Our delta V, final minus initial. So the final is 1.200 minus the initial. Change in volume is 0.520 liters. So I have my pressure, I have my volume. This is where people make mistakes, Jen. I calculated my pressure, right? But when I plug it into the equation, there's a negative out front. Sometimes people forget that negative. Like I said, the math's not hard, it's those darn negative signs that'll mess us up. Yep.
Is it negative no matter what, or what if you have like already negative things that change into positive?
Well, the only thing that can be changed would be the delta B. If delta B is negative, a negative times a negative makes it a positive. But there's always going to be that negative sign out
So
front.
even if it's already like, negative
Even
before.
if P, when you calculate.
Pressure is always a positive number.
Oh,
It just is that there's a negative sign in
Okay.
front of the pressure. And I get 53.6 joules. Negative. So my work is leaving. Any questions on A? Then for B, calculate the total energy change in the system. To calculate the total energy change, we use the first law of thermodynamics. The first law of thermodynamics states that the total energy change so delta U is the total energy change. The first law of thermodynamics states that delta U is equal to Q plus W. So the total energy is equal to your heat plus your work. So to calculate the delta U for this problem, it would be Q plus W. So delta U would be, my Q is positive 550. My work is negative 53.4. So the total energy change is with sig figs 497. So to give this a little perspective here, Sierra, my work is negative. I'm losing work. So it'd be like me giving Matt $53.60. Sounds good, right, Matt? I'm going to give you $53.60. I'm losing work. But on the same token, Jen is going to give me $550. So even though I'm losing $53.60, I'm gaining $550 from Jen. My overall gain, $497. Okay? I'm still gaining energy overall in my system. Doesn't have to be that way. Just in this problem I'm gaining. So delta U tells me the overall change in my system. When you're reading a problem, a little word of caution. They don't always put the negative sign there in the problem when it should be there. They may say something like 550 joules of heat is released, but they don't actually put the negative sign there. They're expecting you to put it in on your own. Because when you read this, Janae, when you say heat is released, that means the value is negative. So if heat is released, I mean heat's coming out. So just be aware that in some textbooks, when you read that, they're expecting you to put that negative sign in for you.
Oh, we're doing good.
Okay. One more example that you're going to see on the test, or not test, worksheet tonight. is that, they are gonna ask you to predict Q, W, and delta U for both movable pistons and fixed pistons. If your piston is fixed, it means it can't move. You'll also hear this called a rigid container. For a rigid container, the piston can't move. So if the piston can't move, what is your value for work? Zero, right? Because there's no change in volume. If you can't change volume, that means your delta V is zero. So if you have a fixed container or a rigid container, delta V must be zero, which means work must be zero. And then you just have to ask yourself what's going on with your heat. If heat is leaving, what's the value of Q, Jen? Negative. So work is zero and Q is negative, then Sarah, what would be the value of delta U?
0 or negative.
Work is zero.
That would equal Q.
Q would equal Q, and what's Q?
Q is
Negative.
Negative. So that's another type of problem you'll see on the homework tonight.
Wait, what is that?